All right, so far we've looked only at molecules that involve atoms that have only s orbitals in them. I'm sure you're thinking, well, what do we do in the case of p orbitals? And in fact, we can do the same thing. Again, we're going to take the linear combination of those p atomic orbitals and make what are called pi or some more sigma molecular orbitals. So let's look at the first case where we have either the 2px or the 2py type of orbitals that we're combining. So they're the same shape. This is the shape of the orbital or the shape of the wave function. And we can call this either 2pxa being combined with 2pxb, or we could say, since it's the same shape, it's 2pya being combined with 2pyb. And in either case, if we first talk about constructive interference, what again we're going to see is that where these two orbitals come together, we're going to see increased wave function in that area. So we saw constructive interference. So again, we can name these molecular orbitals, and these we're going to call, also to point out, there is now a bond axis along this nodal plane, which is something we didn't see before when we were combining the s orbitals. So when we go ahead and name these, we're going to call these pi orbitals. We'll call it either pi 2px if we're combining the x orbitals, or pi 2py. The reason that I wanted to point out this nodal plane here is because this is why it is called a pi orbital. Pi orbitals are molecular orbitals that have a nodal plane through the bond axis. Remember, this is our bond axis here, and you can see there's this area where the wave function is equal to 0 all along that plane. That's a nodal plane. So that's why these are pi orbitals instead of sigma orbitals. So again, we can think about the probability density in terms of squaring the wave function. So now what it is that we're squaring is, if we're talking about the x orbital, it's pi 2px squared. And this is just equal to the square the 2pxa plus the 2pxb all squared, or if we write out all of the terms, we have 2pxa squared plus 2pxb squared, and then this term here. And again, this is our interference term. In this case, is it constructive or destructive interference? Constructive interference. We're seeing the wave functions adding together and giving us more wave function in the center here.